Alright, I'm sorry for those spammers. I can't do anything right now, so I'll actually close it if I can open my mod view. Otherwise, I hope a mod can do it. We will see what happens. No, apparently Farley is not. No, not you. The people who randomly started spamming in the chat, because you know what? We don't care about bigfollows.com. Uh, I'm sorry, but it seems more spam than actual content. So, alright, sorry about being a bit tardy today, but I actually have to compile the problems from scratch because I am not given the LaTeX code by DJ. So I have finished compiling and we'll start soon as I get my board ready. Alright, thank you, I am awesome360 for following. I appreciate that because every time um, we get closer to 50 followers, I'll do another live solve. So 40 followers is my next live solve. Right now I'm at 38. And then after that will be 45, and then at 50, we'll be hosting an ISL countdown. This is when will the next stream start? Or when will the stream start? Give me a second. I'm trying to wait for my computer to load because mainly because I have the problem ready, but basically, let me explain you how I take a problem and I make it into how it looks. So first, I go to AOPS or whatever and I find the problem, and I get the LaTeX code. Then I stole a package from Dennis, because if you guys know Dennis Chen, also known as DJMathman Counts, I basically stole one of his packets that he uses for Mac, and using that package, I compiled the LaTeX code into something that looks really, really nice, and then I have to convert it into a high quality image so that you can see. So what I do is I invert colors because invert colors looks very nice, and then I send it here. So the part I'm still stuck on is the conversion, because the conversion is not all too quick, and it takes a bit of time. So as soon as I get that conversion, also it takes a bit of time for me to load everything into my OBS. So I hope to start within the next 3 minutes. We'll see if I can do that. Oh wow, CNCM math is here. Okay, one day I might actually show you guys how this works, but for now, any second, it should load up. As soon as it loads up in my OBS, we can start. Okay, give me a second. Nope, not loaded yet. Still waiting. Darn, this is taking much more time than normal. Maybe I should go check what's actually happening with my OBS. But all I know is it's eating up my battery. Yeah, that's really all it's doing. Oh wait, okay. No, it didn't load yet. Doctor, we're waiting, so. Oh, okay, interesting. CW here, I have the power, so, oh wow, okay. Well, my moderator's decisions are final, so, yeah, good luck. I'm not going to unmute you by any means. And the problem loaded but doesn't appear. Okay, now the stream is about to start in less than maybe 30 seconds. Alright, 3, 2, 1, let's transition into the actual stream and we will start. Alright, I'm going to trust that you guys can see what I'm doing. If you can't see what I'm doing at any time, just yell at me in all caps in the chat box. My moderators aren't that stingy. What day am I going to live solve AMC8? As soon as the problems are probably released on AOPS. That's exactly when I'll start. Okay. So, let's see. I am opening my thing. Also, guys, when you ask me a question in the chat, right? Remember that there's going to be a slight delay. So you can see the chat window in the top right of the screen that I'm showing. So if you don't see it there, don't be worried if I have not answered, because it's 100% because I'm just like not able to see it. Okay, so I will start as soon as the problem loads up for me. Okay, so what's the problem? We have some horrible looking triangle. It's a 65, 70, 75? What? I've never actually... Oh, this is just a 13, 14, 15 triangle, but like big. Like big. Okay, so this is just like, here's your omega big 13, 14, 15 triangles, and you're going to draw a semicircle. Let's start. Let me draw. Okay, I'm just going to... So here is our triangle. How does... Oh wait, you can't see my screen, can you? Okay. Now you can. So here's our triangle. Let's make it a bit more skewed than this. No, I can't erase it, okay. No, stop. What? Okay, give me a sec. Let's draw a bit more skewed triangle. That didn't auto draw. Let's do a triangle that looks like this. Here we go. No, it just corrects it to an equilateral triangle. I don't think I can do much. Yeah, I can't change it from an equilateral. No, I can't. Oh well. Smart drawing has a lot of things to improve on. 4 plus 5 equals 7. Sounds probably accurate. Anyways, what are we given? A circle with diameter BC is tangent. It's constructed outside of the triangle. Okay. So I'm going to go ahead and draw a full circle, and we're just going to consider the semicircle. Or actually, we can probably just draw the semicircle and get away with it. So here is our semicircle. This is a huge diagram, so let's just zoom out a bit. Okay. So let's see what happens. What does the problem say? A circle omega tangent to that, and also to that. How do I draw this? Good faith. Circle. Okay. It autocorrected to a circle. Now I can just drag this until stuff works. Let's see. Let's just keep dragging until this. Okay, here we go. This is close enough to. This is probably the best I can do. So I'm just going to leave it like this. Okay, here we go. And, oh, we're just looking for the length AX. Alright, so if I draw this segment, here's point X, that's point A, and we're just looking for the length of AX. Alright. So basically, I'm just going to assume that the 60, 75 stuff is only for padding because it literally makes no sense otherwise. And I mean, let's see. So let's see if we can find what does this circle look like, the orange circle. And now that I look at it, it looks more like an ellipse than a circle. Yeah, every second I look at it, it looks more like an ellipse. But, okay. So my first thought is label these points as B and C. And C. Now, obviously one way is going to be to use coordinates, and coordinates are obviously not the intended solution. Maybe, this is a maybe, we can consider the midpoint here M. It doesn't necessarily lie on the line, so I'm just going to draw it off center, like here. So let this be the midpoint, so it's obviously the center of the semicircle. Then maybe we can do some weird Pythagorean stuff with this. I have no idea if this will work. But maybe. So what do you guys think? I mean, I'm going to just assume your view of this isn't as blurry as mine, and I'm going to redraw a few of these things, but in general, I hope this is a good first step and I'm not just completely messing up. Okay, so it's also just randomly adding arrows on the end of my lines, but okay. So the first step is to note that BXC is 90. This will probably be significant somehow. Somehow we need to find, actually, what I'm missing is we need to find the center of this circle. If we call this O, then what do we know? We know that this line, wait, so for some reason it suspiciously looks like this is just the the intersection of the incircle with this semicircle that's defined. Or not the incircle, but the angle bisector. So can we prove that it's the angle bisector? The answer is probably no, because that seems very hard to do. Let's change that to actual lines. Give me a sec. No, not a Bezier curve. Wait, are people still in the chat, or can I just not see the chat? Oh wait, there are 2 more people that followed. Thank you, Asterisk and Best Beast, for following. Another live solve, I guess. Okay, let me check. So are people still here? Okay, people are here. So what can I do? I really don't know what to do. One thing I can think of is introducing the orthocenter, but this is already an in-center like configuration, right? Maybe it is time to coordinate bash. I know this wouldn't be the best idea, but I'll come back to an actual solution. Let's just coordinate bash and see if it's bashable. So, this semicircle. Okay. What? What? Okay. Brian's having too much fun with the mod controls, it seems. Don't know. So I'm thinking that, how do I encode the tangency? Because well, what's going on is just Brian is too excited right now. So what happens if I somehow, how do I encode the tangency, right? That's my biggest concern. Because if there's a good way to encode the tangency, then I'm automatically done. Because the tangency is a hard thing, but I'm not sure how I want to encode the tangency. I mean, scaling down by 5 is what I'm doing anyways. If you looked at my coordinate bash, I started with that, so I'm not sure what it is. I'm pretty sure that somehow you want... What I'm not getting is why is A, O, and X collinear, which should be a pretty trivial fact. But I just, for some reason, I can't calculate it. Like, wait, it does make sense that AOX should be collinear, right? So then why is it collinear? If I can find this, then the rest of the problem is like Pythag, but why are they collinear? Does anyone know? Because, okay, let's see. They look collinear. Can I just say they look collinear, so they must be collinear? Wait, I also think this is fake because I would like to think this is fake because otherwise we have the M lies on the angle bisector. So maybe what I claim is fake. So, yeah. I mean, I'm not sure if this is actually going to be the 9-point circle, but here's what we can do. So somehow we want, so M here, and there's some point here that's called X, or sorry, O, which is our center. And the property of O is that O lies on the angle bisector. It's not the 9-point circle clearly because there are no 9 points. It's tangent to 2 points. I would have thought this was a mixed linear incircle, but there's nothing good for it to be the incircle of. Like, I can't find a good circle, if that makes sense, or a good triangle, sorry. So, and somehow we need to find this point. Okay, so this is definitely, it can't be fully geometric. Oh, hello. Can you guys hear me? This definitely can't be fully geometric problem because it looks like you depend on the length somehow. I might be... Where are people? People are everywhere. I don't know what to do. The only thing I can think of is, you know what? I'm just going to, yeah, you know what? I'm just going to chord bash because I do not see another way to do this. I mean, I do see another way to do this, but I don't think I can do it because it's probably, actually, you know what? I might try one idea. Take the incenter. Law of cosines might work. But what I was thinking of was how do we relate the incenter? And it's simple. Take the incenter, a badly drawn circle, which should be the incircle, and what can we do with this? Well, homothency. I don't know how useful this homothency is going to be, but there's a homothency taking the blue circle to the red circle. And I mean, I'm sorry, but this seems really hard, right? So I'm going to just try one homothency before I give up. Also, no one told me what type of content they were looking for, so I don't know what type of content you want. Alright, so here's the incenter. We're going to put our center here, O, and that's it. So, what am I looking for? I'm looking for somehow we want a homothency taking I to O. And that will, what are these random circles called? The blue circle is called the in circle. I thought that was obvious. The other circle is called the good luck on solving this problem circle or something. Because I have no idea how to use this circle. If we take that homothency, where does points get sent to? I want to say that M gets sent to something that's non-trivial, like this entire like BC circle gets sent to like, I want to say that the circle at BC gets sent to the circle at something else, but I don't, or the orange circle, but that's false. So I don't know. Okay, what else do I know? Well, let's see. If I, okay, also, correct me if I'm wrong, but one sec. First, I'm going to draw the entire circle, so that way we have more context. And correct me if the next thing I say is going to be wrong. Okay. So I want to say, if we draw random lines, that they concur on AX. Specifically the common tangents. No, that's not a tangent. Okay, no. Just... Okay, now if I edit these to be actual lines, they should be tangent. And they should also pass through OX. What? Okay. What? This is not even a line. Okay, I give up. I don't have any characterization of X. I'm trying to figure out a good one, and here's what I claim, but I have no idea if it's true. So if we let these two or tangents intersect, they should intersect on the line AX. But I don't know. I'm pretty sure this is true, because it looked like it was true, right? If I take this tangent and this tangent, they should intersect here. Wait, am I too close to my mic? Wait, that's true because I'm using headphones, so they have to be close. So I am close to my mic. Oh, okay. Oh, that makes sense. That I was confused. Okay, so somehow we have to find like something related to AX. And AX seems bad. Like if I can find this point, I still don't know how to find AX. Like when are you getting a face reveal? When you can use Google and Google up my name. That's probably the best face reveal. I'm not at MV, so you can't find me at MV. Yeah, if you search the internet, you'll find me. So, and it's not a teeth reveal. What? Okay. Uh. Huh. So let's see. How do I do this? Okay. You know what? I'm going to say let's chord bash because this should follow by like Monge's X circle theorem. I think it's the X1 and not the N. I'm just going to call it Monge's X circle theorem. Shh. No need to post it publicly in the chat. So now we show chord bash. This is all the information. So if we call this I don't know, E for X millicenter, because that's basically what it is, we can find the X millicenter pretty easily. So how do we do this? The equation, wait, what's the incenter? The inradius of a 13, 14, 15 triangle is 4. And shoot, I don't have enough information from just the inradius. I don't want to use trig. Why do I not have this memorized? Yeah. What this is basically the best I can do because I am not too well versed with like geotheory, so I have no idea how to use E either, but it's nicer to chord bash because now the advantage is I got rid of the orange circle, so now you only have to find the intersection of AE with this. Is my tie not loose? Okay, that's not my problem. All right. All right. So let's see. Can I somehow calculate the incenter? I should be able to calculate. Oh wait, this is just S minus. 1 sec. This is 5, 12, right? So this is 21 minus 15, 6. So the incenter's coordinates are 6, 4. Cool. That took. Alright. See you later, Kwu. So that's 6, 4. We can find the. So the x minus 6 square plus y minus 4 square equals 16. I'm pretty sure you can't see that. Oh no, you can. And the other one is x minus 7 square plus y square equals 49. And somehow we need to find the common external tangent. Okay. So to find the common external tangents, I'm going to erase the orange circle because it serves us no purpose. No, I can't just delete it. Okay. Now what I'm going to do is I'm going to draw perpendiculars and pray to God that perpendiculars make sense. So I'm going to drop this perpendicular, and these are two tangents. And now we have similar triangles. Oh wait, I could have done all of this, what I'm just doing right now, without coordinates. Shoot, wrong circle. O does not exist as far as I'm concerned. So here. And yeah, and now This can also all be done without coordinates, but I will use coordinates anyways because convenience. 7 comma 0. So similar triangles, right? So this length here is root 17, and the radii are 7 and 4, so that's root 17 to 4 root 17 by 7. So we can do the math. Whoa, okay, you like my bike lock? Interesting what people observe these days. So wait, I'm pretty sure that I'm just trolling now because I literally have everything. So that's 38 by 7, comma 4, I don't know, 16 by 7 plus 4, wait, no, this is fake news. 1628 is what? 44 by 7. Why chord bash? Chord bash is basically the reason I'm doing this is because I found one point that's nice, and I have no good idea of how to do anything other than chord bash. So chord bash is a yay. Yeah, that's basically my story. Okay, I'm pretty sure this is wrong because wait, yeah, I'm pretty sure that what I just claimed or something I did is wrong because does not look like it's the instant center. 1 second. Okay, how do I find this? Yeah, no, how did I get? My question is, how did I get over? Yeah, I trolled this entire thing, didn't I? Okay, so somehow I got over 7, which isn't even correct. It's something to be like over 3. So somehow I managed to turn everything into the incorrect version of itself. And okay, now what do you get? E equals, let's see. That's going to be, I am concerned because this is a multiple of 7. And, oh no, multiples of 7 are actually okay. But is it this? Yeah, it looks like this. Okay. 28 by 3. Okay, so that is E. Yeah, I'm pursuing the extra millicenter idea, but I'm just chord bashing because that seems very fast. A equals 5 comma 12, and we can calculate this line to be, let's see, I'm going to switch colors temporarily or permanently or whatever so we can see the line. The slope, that's a horrible color, I shall never use it again unless I misclick like I just did. Is equal to 12 minus 28 by 3 over 5 minus 14 by 3 is equal to 8. Okay, that's a bigly slope. 8 and y minus 12 equals 8x minus 5. And yes, we have finally gotten our equation. Now, time to bash. Remember, we want negative. I don't know how I'll do my AMC 8 live solve, okay? So y is going to be negative, and now we just plug and chug. Yay. So y is equal to 8x minus 40 plus 28 plus 28, okay? So 8x plus 28, and now I'm going to substitute this in. X minus 7 whole square plus 8x plus 28 whole square equals 49. And let's see, 65x squared minus 14 plus 8x plus 28 seems wrong for some reason. But I'm just going to let it slide because I do not think I want to fix it even if it's wrong. 28 times 16 is what? 7 times 16, 112 times 4, 448. minus 14 is 434x plus, let's see, 28 squared 784. 784 plus 49 is 1. Is that even right? No, that's not right. 833, and this is equal to 49. So we get a quadratic as it was supposed to be. Okay, so if we're using the quadratic, we can say it's the value. No, we can't say anything, can we? Great. So, oh wait, you can't see the last part of my work, right? Okay, I am sorry about that. I'm just actually going to just completely shift to this side. Burn size, I might actually teach burn size. Maybe, we'll see. So I am just going to pray this works, and let's see what the solution should be. Wait, this doesn't, wait, I expanded wrong. Because this has no real solutions. Okay, I am 100% sure it's 8x minus 28. And alas, it's a minus. So all my work is bogus because I forgot the minus sign. Hooray for minus signs. So what was this? 448 minus, so, or sorry, no, now it's a plus. Yeah, so 462. And now time to solve new quadratic. Let's see. 462 squared, that's like what? 2, no, that's, so 4, 4, 4, 3, 1, 2. You know what? Do I even want to do this? Let's say I am going to do this. So this is what? 2, well, I can't write. So it's 462 plus minus root of 213,444 minus 4 times 65 times 833. That's like 54145. Whoa, that's a palindrome. I can't even write it. 54145 over 130. Let's see. 213,444 minus, what's 4 times 54145? That's like, oh god, that's, wait, what? 4 times, that's like 216580. Darn. Where's the top in this problem? This is written by DJ. Class is leaving. That's not good. Oh wait, I forgot to subtract 49. 784. This is 50960. I'm almost done, so I believe the computation shouldn't take too long. Anyways, what is this? 213444 minus this. This is nice. It becomes, wait, okay. Miro was apparently just restarting, so wait. Okay. So apparently what I just learned was Miro was updating, and right now this is nice because this is 462 plus minus 98 over 130. So the x value, we're going to take the larger x value, and the larger x value is going to be, wait, what is the larger x value going to be? I might also have to get my charger soon because my computer is once again dying, as I've told you guys. The larger one is going to be like, what? 56 over 13? Interesting. Yes, this is actually very interesting of a result. I did not expect it to give 56 over 13. Why is it? Okay. Wait, is the larger one 14 over 5? No way 14 over 5 is larger than 56 over 13. Oh, okay, the other one. Okay, cool. So now, as you can't see it, I'm going to just scroll down, and the answer should be, well, what's y square? What's 49 minus... I don't even want to do this. Like... 56 by 13 minus 7 is like what? 91, so 35 by 13. Now if I square this... is this just 84 by 13? Yeah, it's just 84 by 13. This can be done by... Wait, do I want to believe it's 84 by 13? Yeah, it is, right? Okay. So we're just finding AX. So now I can finally claim I am done with the problem, as AX is just going to be stares at the problem. Okay. So it's 11 root 65 by 5. Wait, is it? Or not? I'm not even sure what I'm doing now. No, it's not. Am I supposed to take the other one? What am I doing? Okay, one sec. So we're trying to find AX. And somehow I managed to fail the computation to this level. So if I consider which one's bigger, 56 over 13 is bigger. Yeah, I want to skip. I want to skip this one, but I don't want to do it a dishonor. That's the issue. So I'm pretty sure I'm supposed to take the other value. Why am I supposed to take the other value? It doesn't make sense, though. Right? Chonacho? I don't know who Chonacho is. Brian. Nice. Okay. Wait, I don't understand. How is this failing? More particular, how am I failing? This is, like... I'm basically there. Like, what? Huh. This is very strange. What? I mean, I guess there's another way I can do it. You know what? Should we just skip? One second. Let's see if... How do I start a poll? I don't even know how to start a poll. Okay, I got this. I'm pretty sure I don't, because even if I multiply up, right, I need the denominator to be 5. So what we shall do is... Oh, wait, I'm being dumb. We want the smaller x value. Right. 14 over 5. So the reason we want the smaller x value is because this is on the other side of a. It's not right. What I said was not right. It's not... So all my work is right until the point I chose 56 over 13 to 14 over 5. I should have probably, like, looked before I did stuff, but I didn't. Anyways, this is 28 over 5. And this is wrong. Is it? I don't believe it's got to be a negative 28 over 5. Or something. Yeah, it's a negative 28 over 5. No, I am done with this problem, basically. So if we do this, it's going to be 5 minus 14 over 5, that's 11 over 5 plus 1260 plus that 78 or 88. Huh? Oh, does it just work? 11 root 65 over 5. Okay, I am done. This is as close as I'm getting, because 11 root 65 over 5, you multiply that by 5 because it gets rid of all the fractions, and you're done. If there's someone in the chat who's willing to check if that's right, thank you. I'm also going to check right now on the AOPS thread if that's right, because then also I'm going to get my charger. Wait, no, it's very... Alright, it's very clear that almost anyone's greater than me at Geo because I actually suck at Geo, if you've not seen. So like, if it was comparing me at NT, maybe, but not at Geo. Sorry about that, I had to go and eat something because my stomach was going to kill me. I am now back and we can, I guess, move on to the next problem, which is also Geo, but it happens to be like the second last Geo. Yeah. So apparently, according to DJMathman, his top problems are 3 Geo, 1 computer science, and 1 algebra that looks more like NT, but it's actually algebra. No, I did not. I just ate. Hunger is a very big problem for me. If you see me, like, normally I won't be able to sit for 2 hours without eating. For example, take the JMO, and I ate around every hour. Okay, thank you for chord bashing. Yeah, chord bashing was because I didn't know how to not chord bash. So, as a result, I chord bashed. If that makes any sense. Okay. So, I'm going to get the next problem up and running soon. Okay. Alright, yeah, the chat feed will be a bit lagged. And the reason the chat feed is lagged is because like not everybody's internet connection is the best, and neither is mine. The next problem is coming up. It's also a geo, so I am trying to get it. I'm trying to get it to load onto OBS, but OBS is basically saying no and not loading it. So I am just like, wait. Okay, it finally loaded. And I am going to upload the image and we're going to start. No, it's not loading again. Pity. Yeah, OBS isn't... I mean, OBS is good, but like, it definitely can improve. I.e., it can be much, much faster. If OBS was faster, honestly, like stream starting would take like 5 minutes. Because I literally just put my problems into OBS and restart. But no, each image takes a while to load from OBS. Then I have to hide everything. Then I have to shuffle stuff. Not shuffle, but like put them in a slideshow. And while I've been distracting you with my OBS talk, stuff should load up soon. And hopefully we can start. This geo actually looks nice. I pressed the transition button like 4 times. Okay, there we go. So it's transitioned. At least I hope it has. So now this problem, right? Where am I even writing? Okay, here. So this problem, it actually looks like geo. Like, that I can do. Okay, so for this problem, what are we given? We're given a acute triangle with circumcenter at O. Here's your triangle. A best equilateral, nope, okay. Nope, delete this triangle. Or let's just undo it. And actually, you know what? Let's first draw the circle because circles are hard to draw. Although I do have smart drawing with me, circles are still hard to draw. That's a general rule of thumb. If you have to draw something, always first draw. Can you get unmuted? Why were you muted? If you were muted for an actual reason, then you probably can't. If it was because Carl was botting, then maybe. Actually, it's probably yes. Okay, so we're given this circle and ABC. Okay, A, B, and C. So now what can I do? Okay, that's just Brian. And we are given that AQ is perpendicular to BC. So basically, if you don't recognize this configuration, which Doctor should, if Doctor doesn't, then something's wrong. But this configuration is basically orthocenter reflections, and that happened. Okay, so Q, this is the orthocenter H, and circumcircle of BOC. One sec. Circumcircle of BOC. Okay, that's different than what I thought it was. Let's call this point O. That's not an O, but okay. And that's a circumcircle. So by the way, if you see me drawing horribly, that's because I do draw horribly free-handedly. It's not too bad, but on an iPad it's always worse. Alright. And we shall pretend this passes through point O by memeing this until it works. Let's just keep... Okay, here we go. And that's point O. We shall make it very clear that's point O here. And... oh no, this actually doesn't seem like an angle chase, to be honest. I definitely, like off the bat, I see a different solution that might be nice. Also, whoa, why am I drawing so big? You know what? I'm just going to shrink this entire thing that I've just done because this is pretty big and I can't zoom out too much. How do I select? How to select? Can I even shrink stuff? Okay, here we go. Let's go ahead and shrink all of this because it's large. Okay. Now that I've shrunk and you've seen the secrets of the mirror, okay. Let's keep going. So, no, this actually seems like a good geo because I know some things. So circle of BOC intersects lines AC and AB for the second time. So I'm going to extend these lines. So AC at D and this is E. If OD is 7 and OE is 3, compute AQ. So it seems like you're not given enough information, but this is like the example of 2D turned 3D. So what can I do? Well, first, like, this is a very strange configuration. I'm gonna, what can I say? So if we consider, we're somehow trying to convince, we're trying to convert we're converting a circumcenter configuration to an orthocenter configuration. And that's always hard to do. So that's why this problem's so hard, probably. So basically, like, here's a easy observation to make. DEBC cyclic, so you can get like angle ADE equals angle C. Right? This is like the first thing that I notice. So you get a bunch of angles. Do we know angle ODB? It's angle OCB. Just angle chase everything until something nice happens. OCB and OCB is what is that? That's 90 minus A. So this is actually not that bad of a start. Wait, this is probably a problem you've seen before. So what do we wait? Does this just mean? Is this just very sketchy? Okay. So DO is perpendicular to AB. This is not true in my diagram, but I'm just going to assume it's true in general. Oh wait, also I'm going to quickly switch B and C because that's what the problem asks. So this actually changes a bunch of stuff. Yeah, this one definitely does look like a lot of angle chasing. So I have to switch all C's and B's. ODC equals OBC, this angle B. Okay. So what do I want? So we're given that O is the orthocenter of ADE. And what? How are these? What? I don't even understand. Why is O the orthocenter all of a sudden? Okay. This is probably why we can convert the circumcenter configuration to orthocenter configuration. Because all of a sudden you're given that AB is perpendicular to DO and AE is perpendicular to this. And that means you're going to get this perpendicularity. Okay. What else can we do? How can we do something else? Also, is it just true in general? I'll switch colors that OD is parallel to QE because if someone looks like this, and if this is true, and by symmetry this should mean that EQ is parallel to this, we'll be done, sort of, because we know 3, 7, and isogonals. Okay, so would you want me to consider the isogonal of? Wait, where even is the circumcenter of ADE? No, there's no circumcenter. Wait, so AO and AQ are isogonal. Yes, that's true. These two are isogonal. Okay, AO and AQ are isogonal. That's pretty nice. So how do I do this? Is ADQE cyclic? Okay. Huh. You might be right. I can probably fit a circle around them if I tried. Yeah, so I'm not drawing it actually, but I'm just air drawing it and I can see that there's a circle probably. Yeah, if ADQE is cyclic, then that's really nice. Yeah, no, if ADQE is cyclic and we can get the parallel part, then we're done. ADQE is cyclic, how are we going to prove that? The only thing I can see is radax. Radical axis is the only thing that could probably prove this. Because I don't see anything else you can use, right? So what are we considering? Like ADE? If we look at ADE, the circle, then what's the radical axis? Well, okay, this is probably a really bad diagram for the reason that DE passes through this perpendicular. But yeah, this point is the rad axis or the rad center. So that's AQ is a radical axis. Okay. So here's a proof. Modibus? No, it's not Modibus. So here's a proof that AQDE is cyclic. So what you can do is, if you call this point not D, HA, then what you get is HA equals radical center of ADE, BOC, and ABC. And yes, this is because AQ, what? No, this is because DE intersect AQ intersect A, so this is HA, intersect BC. So this is actually one point. And yeah. Okay. So yeah. So this is, and you get that this is a radical center. So yeah, you do have that it's cyclic. And in fact, do you have anything more? Wait, yes, you have it's a diameter. The reason for this is because it passes through, so we know that AO and AQ are isogonal in ABC, and since AD is antiparallel, or DE is antiparallel to BC, they're also isogonal in or in triangle ADE, and that means that AQ passes through the circumcenter of ADE, so AQ is a diameter. So yes, you do indeed have these are parallel. So yes, we do have this thing. Okay, and that was just a flurry of observations. Thanks whoever suggested that AQDE is cyclic and also the radical axis. Because the fact that DE passes is like, it's a well-known property from what I remember, but I didn't actually think of using it until you said that. Because if you're trying to prove it, then you want to show that AQ is the rad axis, so you work backwards essentially. Okay, now what do I do? So what are we even trying to find? AQ. What? Isn't that just like... What? Huh? What? How do I find AQ? Okay, do we have to somehow use this fact that this is a parallelogram we have? Farley agrees that GO is good. She will say that every day. But do we have to use the fact that this is a parallelogram? Oh, can we use parallelogram law? If we can, that's actually just going to be funny. For those of you who don't know what parallelogram law is, it says OQ square plus DE square equals 2 OD square plus OE square. This is one of the funniest laws. Yeah, this finishes, right? Because this is just going to be equal to QA squared because of the perpendiculars. So this is just 2 times 58 to 29 QA. Alright, that was not a bad geo. That was actually a pretty nice geo in my opinion. I'm just going to quickly check the answer on the AL side because I am not confident in my answer. 2 to 29. Yes. Okay, nice. Alright, let's move on to the next problem. Wait. Alright, so I was trying to unmute, but OBS decided to not even let me unmute for like the last 5 minutes. But, so that's it for the CMIM CGO. I believe that DJ had one NIMO problem that was also Geo. But now we're going to move on to something that's probably harder than the Geo, which is computer science number 10. And this is basically a fancy way of saying horrible combo because it's literally a graph and you'll see what I mean as soon as I show it. Give me a sec. Okay, OBS, please work this time. I'm counting that you work, and if you do not work, I will be very sad, as will the 8 people watching the stream. Alright. Okay. No, doesn't load. Okay, finally loaded. Give me a sec. Okay. Press the transition button. Farley does say GeoGood because that's Farley's top subject, right? Okay, it didn't transition. I'm just going to spam the transition button. Tell me if you guys actually see the CS problem. Do you guys see it now? Because it's saying that you guys see it, but I cannot. I do not want to trust my OBS. Okay, here we go. So let's start. So this CS problem is probably very high quality, and by probably I mean it is. So basically you're looking for okay, basically this is combo, but DJ put it as computer science. I want to say this is going to be a recurrence relationship because it literally looks like recurrence. So we could probably just define the simple recurrence and hope it works. So what if there's only one vertex, right? Then if there's one vertex, then the problem is trivial. The answer is one graph. This has to be a connected graph. If there's two vertices, what do we get? Well, we start on V1 and we go to V2. So there's really only one graph. Three vertex. Well, we start on V1 and we go to V2. Then we go to V3. And the condition is that V1 can or cannot be connected to V3. We don't care because it doesn't matter. So there's two graphs. Wait. Okay, this is a little one. So, wait. Is this directed or indirected? Or undirected? Undirected. Okay, cool. So wait, not necessarily. This can okay, so there's actually three graphs. I will explain why. So it can either be this graph or it can be this graph. And the reason the second graph works is because you go to V2, you can't go anywhere, and you go back. Okay, so this is 3. 4 vertices are going to be a pain to count. So it's probably going to be some nice recurrence. So, is it possible? So clearly, like, this is an issue, right? If it's a distance of 1 away, right? If the final vertex is 1 away rather than 2 away, then it's different because we just saw that 1 away has different amounts than 2 aways. If that makes sense, what I'm just saying. So how do we do this? Recurrence, right? So yeah. So basically, if we go to n minus 1 vertices, right? We do this normally. And now we can put the last vertex at any place. So let's say that the distance equals d. We can put this from, so there's n minus 1 vertices, and we can put this thing from anywhere from d to n minus 1. And if we put it at this certain location, there are going to be how many graphs? For each of these, there's going to be 2 to the d. So I'm not sure if wait, does what I'm saying even make sense? Sorry. Like, does anything I said make sense? Because you can connect it to any of the first d without it mattering, right? But then the next one you connect it to actually does matter. So you look at the first one that you really care about, if that makes sense. So I'm just going to explain it to you guys because I think the hard part about this problem is probably if this logic actually works. So that's why I'm explaining it. So if it's like obviously wrong, you guys can tell me. So let's say I took this graph on 3, or let's say I wanted to connect a graph on 4, such that the vertex is 4 away, right? And let's count how many there are, such that V3 is 4 away from V1. Alright, so let's not draw anything in yet, but let's just label as a point of square. Sorry about that. V1, V2, V3. Now, V4. We first can take any of the what do you call it, V1s that go through. Wait, is it D or D minus 1? This is a D minus 1, and 2 is a D minus 1. Or is it D? It might just be D. Okay. So what distance are we doing? So we're doing a distance of, let's say, 1. So if it's a distance of 1, it has to be directly connected, right? You can't have it any further away than just direct, right? So, yeah, I'm not messing anything up, and yeah, so you have to directly connect it. And now how much can you add? Because it takes the priority in the way it does the priority queue. What can we write down? Well, the value of this, if we call this recurrence s of n comma d, well, the value of s of 4 comma 1 is going to be equal to, you can take any graph on 3 vertices and this works. So any graph on 3 vertices, if that makes sense. Because you can always just do this trick of appending the stuff and it'll work. Now, if we're having it a distance of 2 away, not 1 away, we can still connect it to V1. But we also have to connect it to either V2 but we also have to connect to V2, sorry. And we can choose whether or not we want to connect to V1. So S of 4, 2 is going to be 6. Now, same logic, S of 4, 3. The first two are optional, and now we must have it after the 3. So this is 8, because there's 2 choices. Alright, so if this makes sense, our recurrence is actually quite simple, and that's probably going to bite me when I say simple. S of nd is equal to 2 to the d sum. Wait, does this work? Yeah. D minus 1 j I equals d minus 1 to n minus 1 of s of n minus 1 d minus 1. So yeah, now I guess it's compute time. Just make a table and pray. So I'm actually going to cut it off at this problem today because people are starting to drop off, because I understand it's pretty boring watching me fail problems. Also, these problems are hard, so it makes sense. But yes, I think this problem was easy because the algorithm is just you just recurse, because that's entirely what DFS is, and then after that you just finish off like this. So if I'm calculating, right, let's see. Ignore my poorly drawn table. One maximum distance is 5. I don't even know why I included a 0, because this is all big zeros, but it probably helps in recurrence. 1, 2, 3, 4, 5, 6. And we got to find the sum of everything in the sixth. So let's see. 0 and 0 here. 1. We calculated these 1, 2, and 3, 6, 8. I'm just going to trust my calculations are right. So this one is so 3 plus 6 plus 8, 17. That is 3 plus 6 plus 8 times 2, 34. That is 6 plus 8 times 4, 56. That is 8 times that, 64. 10, 24. 56 plus 64 times, so that's what? 120, 960. 34 plus 56 plus 64. That's 154 times 4, 616. God, this is 6th row, right? Okay, phew. 171, and 342. So yeah, now you add these numbers up. And I'm going to quickly do that. 4 zeros that, so carry 1, 2, 6, sorry, I wrote it down. 2, 6, 1, 3, 0, carry 1, carry 2, 10, 9, 21, 27, 31. 3113. Yay. And I'm pretty hopefully sure that this is the right answer. And with that, oh, you guys can't see my screen as normal. And with that, I am going to end. Because I think that the viewer rate has dropped down quite a lot, and what I'm just going to do is I'm just going to postpone the last 2 prompts to like another day where we have more viewers. So thank you all whoever followed, and I'll see you next time.